Okay, jadi sorry. Macam tak logik kan? 70 macam tu. Sekejap. Okay, boleh tak kita menjerit beramai-ramai kerana this thing is not, you know, okay. Webex tak nak pergi kerjasama hari ni. Okay. If this is 60, then 70 should be probably at the very end of the tail, right? So this is 70. Okay, jadi awak pun cari Z 70 tolak 60,000 and then divide by 2. Okay, berapa jawapan ni? 5 kan?
5.
Yeah. So can you find R5? What is R5?
Kosong.
Okay, so this is like 0.000000 something lah. Okay, so that's why your calculator will give a value which is about 0. Okay, so apa maksud probability is 0? What does it mean? Okay, let's say a guy, for example, Hakim lah. Hakim, dia tanya siapa Nabila. Nabila, sorry lah nama Nabila keluar kat sini. Dia tanya, Nabila, apakah probability yang awak akan belanja saya makan pizza hari ini? Okay, Hakim tanya Nabila. Jadi Nabila pun jawab, the probability is 0. So what does that mean, Nabila?
It will never happen.
Yeah, it will never happen. Very well done. Okay, Zamri yang jawab tu kan? Ke siapa yang jawab tadi?
Zafri, madam.
Apa dia?
Zafri.
Hazafri.
Amma Zafri.
Okay, Amma. Okay, jadi probability is 0 means that it's going to never happen ataupun tak akan berlaku. Jadi bila tak akan berlaku maksudnya, okay, is it reasonable to conclude that any of the trucks were driven more than 70,000 miles? So the answer is no, is not going to happen. Tapi nampak tak perkataan explain? Okay, jadi kalau awak diploma level, awak cakap no dan jawab sikit tu dapatlah markah penuh kan? Tak terkelam 4 markah kan? Okay, but degree level bila disebut explain, awak explain lah. Why? Okay, so no because, okay, from your calculation, okay, with mean 60,000 and standard deviation provided as 2,000, okay, you know that from the calculation of Z, okay, the probability value of the trucks driven more than 17 miles is 0%, which means that, okay, there will be, no trucks are driven more than 70,000 miles, and hence your conclusion. Okay, jadi itu adalah apa yang perkara, among things that can be asked using normal distribution. Jadi sebenarnya bila awak guna normal distribution, you can find the probability of something which is more than a value, more than probably here, ataupun kadang-kadang more than, okay, more than this value here. Okay, value kat sini more than, dia nak tahu. Okay. Okay, I really hate this thing. Okay, sorry Okay, sangat sakit jiwa guna pensilnya. Okay, or is kejap. Okay, can someone share me the pencil because it doesn't appear on my screen. Can someone share the pen? Okay. Okay, thank you very much. Okay. Now, more than can be something like this, more than a value here, okay? Or more than can also be something like this. You have a value here, and then, okay, you are asked to find what is the probability of more than X. Okay, or sometimes you are asked something like less than. Okay, let's say you have a value of X here. Okay, jadi dia nak tanya less than X. Okay, jadi saya harap awak boleh gambarkan awak nak guna table yang mana. Or sometimes, okay, you have X here. And then you want to find something, okay, the probability of less than X. So this is the area here. Okay.
Madam,
Yeah.
ada dekat apa ni, dekat chat box tu dia ada Ashraf tulis, dia cakap kenapa still lorik kalau probability dia adalah 1. Saya rasa tu merujuk pada soalan D tadi tu kot.
Oh ya, probability adalah ni, kenapa still lorek? Okay, kenapa still lorek? Okay, kalau saya tadi kan 60, 70 duduk sini kan? Betul tak? Kenapa still lorek? Okay, because kenapa still lorek sebenarnya kita ingat tak? Kita punya normal distribution dia asymptotic. Jadi dia tak pernah touching the x-axis, right?
Betul?
So that's why I don't know. Sebenarnya macam ni, kita tak tahu 70 ni duduk kat mana, right? Tapi kita lorek juga sebagai gambaran kepada kita, okay? Sebagai apa orang panggil guidance for us. Okay, we want to know this is the area. Kata kalau awak tak lorek, maknanya macam ni ha. Okay, awak bagi sini. Awak pun letak 70. Lepas tu awak pun senyap. Kan? Jadi mana saya nak tahu awak tengok you are looking at which area, right? Okay, so this is just a guidance, and then kebetulan pula awak dapat area ni sebagai almost zero. So this must be a very small area. Okay, it is not zero, but it is almost zero. Okay?
Okay.
Okay. Okay, jadi itu adalah discussion on what we have done. Untuk soalan yang kedua tu, saya akan provide the solution, okay, for both questions, and then you can check your answer according to the solution. Okay, hopefully you will understand further on how to use the normal distribution. Jadi sebenarnya exercise ni hanyalah untuk awak faham macam mana nak guna normal distribution, macam mana nak guna probability, and the probability can also guide you to find the percentage. Okay? Bukan semata-mata probability, tapi juga awak boleh convert it to percentage. Okay. So then kita pergi kepada sampling methods and central limit theorem, but actually we have done this, tapi tak apalah, kita tengok semula. Okay, sampling methods hari tu awak dah buat. Okay, you already did this as your exercise, how to select sample, and then why do you sample. Okay, and we already know why we sample, because we want we want we know that the sample results are usually adequate to describe your population. Okay, and we also know that if you want to contact the whole population, it will be not only time consuming but also very costly. Okay. Okay, and there is something called probability sampling, in which this is what we're going to do today. This is types of probability sampling. Okay, sekejap Okay. Okay, cuba tengok ni. Distribution of sample mean. Okay, jadi apa yang berlaku adalah hari tu kan awak setiap group ambil 20 sampel, 20 sampel, 20 sampel, let's say. Okay, now apa yang berlaku dekat sini adalah setiap kumpulan tu, katakanlah dia looking at the same thing. Okay, so in this case dia tengok mean gaji, okay, hourly earning. And then you select different sample. Okay, katakanlah setiap sampel 10 orang, 10 orang, 10 orang dan awak ambil lah readings from each group, and then you make something called distribution. Okay, jadi awak buat table ni, buat table dan awak buat graph. And then if you look at the graph here, okay, what is the shape of this graph? What is the shape of this graph? Okay, macam rendah kiri, rendah kat kiri kanan kan, dan tinggi dekat. Okay, yang ni mungkin tak nampak sangat lah shape dia macam mana kan. Okay, but this one it looks like, something like low at the end, on the left, and then increases in the middle, and then ke bawah turun pula. Okay, so basically apa yang berlaku kat sini adalah dia cuma nak tunjukkan something called limit theorem. Okay, in which, okay, look at the central limit theorem here. This is a very important theorem in statistic, whereby for a population with a mean of mu, jadi kita ada mu and sigma variance, sigma squared. Okay, the means of all possible samples of size n generated from the population will be approximately normally distributed. So this is a central limit theorem, di mana sebenarnya apa yang dia cuba bagi tahu dekat sini adalah, okay, for a sample, as sample size increases, okay, as sample size increases, okay, the sampling distribution, okay, okay, will go towards normal. Okay, ini je sebenarnya apa yang cuba disampaikan. As sample size increases, your sampling distribution will go towards normal. Okay, kalau tak faham juga, cuba kita tengok example dekat sini. Okay, if you look at the examples here, ini adalah population pertama, population kedua, population ketiga, population keempat. Okay, so 1, 2, 3, 4. Okay, so we have 4 different population with 4 different graph. Okay, so this graph represent population 1, population 2, population 3, and population 4. Okay, but can you describe the shape of this population? Okay, yang ni macam ada parabola macam tu, ataupun inverse parabola, and yang ni macam triangle, this one rectangular, and this one is half inverse parabola. Okay, now, okay, apa berlaku dekat sini? Nampak tak? Okay, this is population and these are sampling distribution. Okay, if you look at the size here, okay, untuk distribution yang pertama, kita ambil size 2. Okay, dari population pertama ni kita ambil sample size 2, 2, 2, 2. Jadi ingat tak hari tu grup kita ada berapa grup dalam 20 grup kan untuk develop a graph here for sampling distribution. Okay, nampak tak shape dia? Okay, shape dia macam ni kan. Okay. And for certain population, you are doing the same thing. Ambil sample size 2. Okay, ambil sample size 2, 2. Dan ini adalah bentuknya. Okay, as you increase sample size, okay, cuba tengok the shape of the sampling distribution. Okay, is getting towards a bell shape. Nampak tak ni? Bell shape, bell shape. Cuba dekat sini dia macam skewed sikit. Okay, but as you increases the sample size up to 30, have a look at the shape of the sampling distribution. You will identify that all 4 have the same shape. And this is called a bell shape or normal. As sample size increases towards a larger number, okay, jadi size tu akan, okay, the shape of the sampling distribution will go towards normal. Okay, jadi ini adalah penting sebab kita akan attempt, okay, a question like this. Okay, cuba tengok Okay, cuba tengok. Okay, quickly. Okay, quality assurance of department for COLA. Okay, maintains records regarding amount of cola in its jumbo bottle. Okay, now the jumbo bottle, of course, bila mesin masukkan air ke dalam botol, mestilah ada sedikit variasi lah. Okay, but the amount varies from one bottle to next, but Cola Inc. does not wish to underfill the bottle. Jadi dia tak naklah kurang sangat, but at the same time it cannot overfill. Jadi jangan terlebih sangat, nanti membuat-buat keluar kan. And then it records that the amount of cola follows normal probability distribution. Okay, mean amount per bottle is 31.2 ounces. So this is mu. And the population standard deviation is 0.4 sigma. Okay, now the quality technician randomly select 16 bottles from the filling line. Jadi ini adalah sampel awak, N. Okay, and the problem is, nampak tak ni? Awak dapat 31.38 ounces. Whereas the mean should be, okay, your aim is 31.2. Jadi macam mana? Sepatutnya awak letak 31.2 je dalam botol. Tapi bila awak pilih 16 botol, didapati dah terlebih kan? Nampak tak? Okay, dah terlebih. Okay? Jadi soalannya, adakah okey, awak tahu ini terlebih kan? Terlebih daripada 31.2. Tapi awak punya dapatan adalah based on these 16 bottles. Jadi soalannya, adakah awak nak stop mesin semata-mata sebab 16 botol ni, daripada 16 botol bacaannya melebihi 31.2. So macam mana awak nak decide? Okay, because you have learned statistics, jadi awak kena guna cara yang betul lah. Kalau awak tak belajar statistik, mungkin awak adalah seorang makcik yang tak pernah belajar statistik. Okey, mungkin duduk kat Batu Rakit, kat kampung. Bila tengok je macam ni, masuk dalam 16 botol, ambil 31.38, makcik pun cakap, okay, stop. Kita kena stop machine ni. We need to calibrate the machine in order for us to get a better feeling lah. Okay, jadi nak dapatkan 31.2 semata-mata awak tengok 16 botol ni. Okay, so is this an unlikely result? Adakah, okay, is it a significant value? Okay, itu persoalannya. So, sebenarnya inilah apa yang kita akan buat. Okay, that is in order for us to determine the probability of a sample may falls within a particular region. Okay, we're going to use Z is X bar minus mu divided by sigma, and this sigma should be divided by square root of N. Okay, kenapa begitu? Sebab X bar ni adalah mean kita tadi, 31.38. Mu adalah mean of the population, 31.2. And sigma, okay, sigma kan tadi ada kan? Sigma of the population. And then N is your sample size 16. Okay, jadi kita punya meeting ni akan berakhir dalam masa 1 ataupun 2 minit lagi. Okay, so we're going to attempt this question. Okay. Jadi kita pergi kepada WhatsApp lah nanti ya. But sebelum pindah ke WhatsApp, okey, jadi tadi kita ambil 31.38 tolak 32.20 and then bahagi dengan 0.2, ignore this sign here. Rasa tak betul ni kan. Okey,